Hello, this is Amy from Made for Math, and I am here today to talk to you about factors of a number, greatest common factor, and an application of greatest common factor, where we can use greatest common factor in fractions. And you might have watched last week's video where Dirk explains greatest common factors and models finding the greatest common factor of two numbers using these number tiles. So I'm going to start off with a quick review of factors and greatest common factor. So factors are numbers we multiply together to get a product. Let me give you an example. Let's say we have 8 times 3. And 8 times 3 equals 24. The 8 is a factor. And the 3 is also a factor. And the 24 is a product. Okay, and we're going to start off with finding the factors of the number 4. So I'm going to erase my work that I have over here. And start off with finding the factors of 4. So what I'm going to do is I'm going to grab this number tile that is 4, and I want to find all of the numbers that I can multiply together to give me a product of 4. So I'm going to start off with my ones tile, see how many of these ones are the same length as the 4. Okay, so I was able to find 4 of these ones are the same length as the 4. And I'm going to check with the 2 tile, find that 2 of the 2's tiles are the same length as 4. And 3, I can already tell, is going to be too big, and I know that 3 times nothing is 4, and I already have a number 4. So these are all the factors of 4, and I'm going to write these out in a list. There's a couple different ways that you can write factors. If you watch Dirk's video, he shows you in kind of almost a rainbow fashion. You can also write this out as 1 times 4 equals 4. And we also found here that 2 times 2 equals 4. So if I want to list out the factors of 4 in order from least to greatest, I would say that they are 1, 2, and 4. And I don't need to list the number 2 twice. I only have to list it once. So the factors of 4 are 1, 2, and 4. Okay, now I'm going to jump over here, and I'm going to find the factors of 12. So first I'm going to check my ones. Looks like I can fit 2, 4, 6, 8, 10. I can fit 12, okay? And that works out because 1 times 12 is 12. I'm actually going to go ahead and write this over there. 1 times 12 equals 12. And then I'm going to check for my 2's tile. 3, 4, 5, 6. So I can fit 6 of the 2's tiles. So 2 times 6 equals 12. And then check the 3 tiles. All right, looks like I can get 4 3 tiles, the same length as 12. So that's my model of 3 times 4 equals 12. Then I'm going to check the 4's. I can fit 3 of the 4's tiles, so that's my model for 4 times 3 equals 12. So as you can see so far, I have a lot more factors for 12 than I did for 4. And let's check 5. Nope, that does not work because 5 times nothing is 12. And let's check 6. Oh, I know 6 will work because 6 is half of 12. There we go. So I have 6 times 2 equals 12. And then I'm going to check 7. Oh, 7 does not work. 7 times nothing is 12. And 8 is also too big. 8 times nothing is 12. 9 is too big. 9 times nothing is 12. And 10 is too big. And 11 will be too big as well. So my factors of 12 are 1 times 12, 2 times 6, 3 times 4, Now 4 times 3, when I get to writing that out in a list, I don't have to repeat those two numbers. The same with 6 times the 2 or the 2 times the 6. So factors of 12, 1, 2, 3, 4, 6, and 12. These are my factors for 12. And my factors for 4 were 1, 2, and 4. So if I want to find the greatest common factor of 4 and 12, I'm actually going to come over here and I want to make a copy of that list. Oh, the only thing is I don't think I can take that copy to another page. Okay, never mind. I will leave that right there. I'll go back over here. So I'm just going to write these out. I have 1, a 2, and a 4 for 4, and for 12, 1, 2, 3, 4, 6, and 12. And I want to find greatest common factor. So which factor within these two lists do I have the greatest number? So I know that 1, they both share 1, but they also share some other numbers. They both have a factor of 2. Let's see, 4. Oh, look, here we go, right there, 4. So the greatest common factor of 4 and 12 is 4. Okay, so you might be thinking at this point, well, this model is great, but when am I going to use greatest common factor? So a common area that you will use greatest common factor, or you will apply it, is simplifying fractions. Sometimes simplifying fractions is also called reducing fractions. So if you were to simplify a fraction, you want to find an equivalent or equal fraction that has the fewest amount of pieces. So let me give you an example. Let's say we have the fraction 4/12. I'm going to go ahead and model 4/12. Okay. And I want to find a fraction that equals 4/12, but uses less pieces than 4/12 uses. And so this is where greatest common factor comes in. And you might have remembered from before, we were finding the greatest common factor of 4, and we were finding the greatest common factor of 12. So if you ever need to simplify or reduce fractions, you can find the factors of the numerator, so in this case 4, the amount of pieces I have, and you can find the factors of 12, the denominator, or the size of my pieces. And then the greatest common factor that your numerator and your denominator have in common is the number that you can divide by. So let me show you, for example. Change colors here. Okay, so I know that the greatest common factor of 4 and 12 is 4. So I'm going to divide 4 by 4 and also 12 by 4. This 4 or 4/4 right here is what we like to call it, made for math, a copycat 1. Let me type that out. Copycat 1 is a fraction that equals 1 whole. And we call it a copycat because if you have a younger sibling or maybe an older sibling, I'm sure that at some point in your life you have copied each other. So you've said the same thing one after the other. So we call it copycat 1 because we have the same numerator and denominator, and it equals 1. So I can divide or multiply any fraction by a copycat 1 or a form of 1, and I will get an equivalent fraction. So if I divide 4/12 by 4/4, I will be able to simplify my fraction. So if I do that, change my color again, I know that 4 divided by 4 is 1, and 12 divided by 4 is 3. So that gets me down to 1/3. So I'm going to go over here and check to see if 4/12 does indeed equal 1/3, and it does. It's exactly the same size, exactly the same length. So these are equivalent or equal fractions, but 1/3 uses fewer pieces than 4/12. With 4/12, I have 4 pieces cut into 12ths, and with 1/3, I have 1 piece cut into thirds. So this is one way that you can use greatest common factor in other areas of math, and that is with simplifying or reducing fractions. Hope to see you in upcoming videos.